Hey folks, Joseph Kursky here with you on an important topic, non-latitude longitude coordinate systems. Now there are hundreds of other types of coordinate systems in existence because there are many needs across a wide variety of sectors of society, from architecture to zoology and literally everything in between. You have been using the most common coordinate system, latitude and longitude, probably most of your lives. Other common ones though are the state plane coordinate system in the USA, the UK, the Australian, Indian, and other national grids, and the UTM or Universal Transverse Mercator system. Have you ever found a disc, a surveyed disc of copper or aluminum in a sidewalk or in the rocks on a mountain peak? These survey markers helped anchor these coordinate systems over the past 200 years, although they are less needed now given advancements in GPS, GIS, and geodetic models. No matter what system is used, it is important to use the annotation carefully. Either use the cardinal directions north, east, south, west, or a negative sign to designate west longitude and south latitude, but use one of these two types of annotations. Omitting these annotations leaves ambiguity. The Universal Transverse Mercator or UTM coordinate system covers most of the globe, except for the poles, dividing the world into 60 zones that are each 6 degrees wide. These zones are numbered consecutively, beginning with Zone 1 between 180 and 174 west longitude, and progressing eastward to Zone 60 between 174 and 180 degrees east longitude. In each zone, coordinates are measured north and east in meters, thus northings and eastings instead of latitude and longitude. The northing values are measured continuously from 0 at the equator in a northerly direction. To avoid negative numbers for locations south of the equator is assigned an arbitrary false northing value of 10 million meters. A central meridian through the middle of each 6-degree zone is assigned an easting value of 500,000 meters easting. Grid values to the west of this central meridian are less than 500,000, to the east more than 500,000. Since multiple zones could have a coordinate of, let's say, 3,500,000 meters northing, 710,000 meters easting, it is important always to specify the zone, and ideally the sector of the zone indicating how far north or south in the zone the coordinate is located. Thus, a coordinate in UTM may be given as 3,500,000 meters northing, 710,000 meters easting, UTM zone 14T. Knowing the above information that I've just described, determine the following. Point A here is plotted in a UTM coordinate system as 4 million meters northing and 550,000 meters easting. Point B is plotted in the same zone at 4,100,000 meters northing and 550,000 meters easting. How far is point A from point B in meters, in kilometers? What direction is point B from point A? Point C is at 4,200,000 meters northing and 570,000 meters easting. What direction is point C from point B? How far is point C from point B in meters, kilometers, miles, whatever units you want to use? How many meters east of the central meridian of a UTM zone is a location that is 710,000 meters easting? How many kilometers east of the central meridian of a UTM zone is this same location? Access Geoplaner, PLANER.com, an interactive mapping tool, and enter the address 1401 South 32nd Street, Manitowoc, Wisconsin 54220. Geoplaner shows the location of that geocoded position in UTM, decimal degree, and degrees, minutes, seconds. See this Geoplaner map showing 4 different coordinates formats for a given point on Earth. Note the formats for the street address: UTM, decimal degree, decimal minutes, and degrees, minutes, seconds, respectively across the top of the Geoplaner interface. Use this same Geoplaner website to locate your own residence or campus or a famous landmark somewhere around the world, such as the Eiffel Tower, paying attention to and comparing the values above the map. Thanks for watching, and I look forward to hearing from you.